No oil on the dipstick. Well, now we know why this code is there. So let's diagnose it, find out where the oil's going and what problems it's causing. So P0011, which you saw on there, is a very common code nowadays with almost every modern car because all the cars come along with these. And that is a VVT solenoid, which stands for variable valve timing. So computerized, the timing chain, oil pressure, there's a clue right there, sends a message to the advanced timing and the timing of the engine. So low oil, she's not getting the message. So she doesn't communicate with the computer and say, hey, we need to advance the timing. Develops a tick sometimes, timing chain doesn't get pressure to it. There's a lot of issues going on here. So very common code nowadays, and one of the easiest ways to avoid it is keep up with the oil changes. I personally do 5K. You can do 7K if you want. I use full synthetic. You can use synthetic blend. It's up to you. Look in your manual, make sure you use the right oil content, meaning 520 or 020, because that matters a lot to these engines. If you overburn oil, then we got a burning issue. If you have an oil leak, we have a leak issue. So let's diagnose this particular one and find out where that oil's going, because we still have 2,000 miles on the oil stick. So that means that 2,000 miles and it's that low, we're either losing it or burning it. Let's go into it. So the first thing I'm going to do before I lift this up and check for oil leaks, I just want to identify the VVT solenoid location. So I'm going to take the air dam cover off and the engine cover, and we can go from there and just see what we find as we go. Well, that's not factory. So like I talked about earlier, a VVT solenoid is extremely common nowadays with all these new technology and what it does for timing and advancing of the accelerator. It does, it plays a big part in a lot of the engines and how they run. And it's not uncommon to have this code. So here we have, this is going to be the left bank and that's going to be the right bank. And here is one of them right there. That is actually, thank goodness, the one that I have the code for, because it does say intake or exhaust VVT solenoids, and this is the one I have. That one, unfortunately, this upper plenum would have to come off and get to it, but we can at least get to this one and give it a good diagnostic and find out through the schematic if the cams, these are the cams heads right in here, if these cam sprockets are advancing or de-advancing, negative or positive. And if those are working properly, it comes down to possibly just the low oil or bad VVT solenoid. So with code P0011, you have to check your oil level. So if there's no oil level, you're not sending the proper oil pressure to the VVT solenoids. So you're going to get code, right? Makes sense? So first thing you need to do is make sure your oil level is perfect. I'm not going to do a complete oil change because if I do end up changing the VVT solenoids, which I'm pretty sure I'm going to do, but I'm going to test them first. But I have to have the proper oil level. So we already know that the level is not correct because we checked that out. And it actually doesn't even show on the dipstick. So hopefully I can add like 2 quarts to get it to register on this dipstick. So we're just going to put some oil in. Just going to funnel it. So we're going to show and follow an actual test from the manufacturer for this VVT solenoids for both of them. And we're going to conduct it in the vehicle. But I'm also going to say, if you obviously don't have access to the printout of the schematic and all that, I'm going to show you how to just bench test it. And we can just do a quick test to see if that solenoid's frozen. It's pretty common that they freeze up. A lot of them freeze up due to the lack of oil changes, which the gunk in there's an actuator plunger that opens and closes, and it's clicked by a resistor. So if that solenoid resistor is trying to click, but that plunger is all carboned up with bad oil, it's not going to open and close fully. So we're going to see if we can see a difference. Maybe it's not even clicking if I put power and ground to it, and that will be obviously defective. So yeah, we added just about 1.5 quarts, and here we are. We're right at the full mark. It's perfect. So we're gonna, and look how clean it is. So that tells you that it wasn't mixing very well. So we're just gonna go ahead and, now we're gonna run the test. And we know the oil is full, so the pressure will be proper for this VVT solenoid in the back one. Put the cover back on. Hey now, okay, now let's look. Got her up in the air. We're gonna see if we have any oil leaks because of the oil low level on that dipstick. So let's see what we got. We got a pretty rusted car, but it doesn't help that, you know, they're old. This is an 06, but we have no major oil leaks. There's no dripping, very little right here, probably just from the actual drain plug gasket. And look at the timing belt area. It's actually pretty good. Now, this thing has about 140K on it, the engine, and still runs, starts right up and runs, but we do have that code. So now, if we have no oil coming out of anywhere that's massive, that can accommodate or account for the actual loss of, it's not showing on the dipstick. So this takes like 4.5, maybe actually 6 quarts in this, believe it or not. A lot of the 3.5 Nissans take quite a bit of oil. So, geez, we're pretty low. We could be even 3.5, 4 quarts low. So the other place you could be doing is burning the oil. So I'm going to show you a little detective work that I've done through the years when I've learned from what I've learned from. So we'll go back and see. And, you know, the exhaust is still somewhat in contact. It is broken right here, and you can see someone tried to make a little repair. And they were successful because it broke after that. But here's where my images start to tell me a lot of things. So it's got the chrome tips on them, which is factory. But you see inside here, you're going to have soot because it is combustion, right? But not that heavy. And then you can actually see like a mystery trail of it going kind of up. So that tells me that the soot that was coming out of the back, the carbon monoxide, the exhaust, had weight to it. And that would mean to me that there is oil in it when it's burning. Not so bad that the guy behind you is like, geez, I can't even see, and you're leaving a trail of smoke behind you, but enough that you're not gonna notice with your naked eye, but it's burning it and it's leaving the valves. Valve seats, rings, whole bunch of internal engine issues. But right now, we're gonna keep this thing running by finding out if that VVT solenoid is any good or if it's just because it's low on oil. So as you can hear, we got this thing running. We're gonna run it for a while and see what codes we get out of it. Technically, I've done it. I've been running this for a while. So I want the engine to get hot. I hear the idle's not coming down. That's not a good thing, there's a problem there. But now I've got a misfire, which I didn't have before. So I'm pretty excited about that, that's kind of cool. So now I've got a misfire. I got VVT solenoid codes. I have low oil consumption. I'm burning oil. This thing's got a lot of problems. But here's our codes that we have so far. Now this one I'm not too worried about. It is the VVT code, but I cleared the original code, the P0011, to see what I would get. But I disconnected it at one point with the key on to check my connection. So I know that's there. But I want to go to gonna read the data. I want to see the live data on this VVT. When I ground out the solenoid with it running, and I got to tap it to a ground, and that's going to be activating kind of like that solenoid. If the solenoid's bad right now, which I'm 90% sure it is, but I want to bypass it and see if I can get the cams to advance and negative advance, back and forth, back and forth. So there's no such thing as negative advance, but go positive and negative by manually clicking it like that solenoid. If it doesn't do that, then I also have cam issues. This thing's a mess. So now we get to do the diagnostic part of this. I know I might sound a little excited, but that's what we live for as technicians. We love to solve puzzles. So I've got my schematic and I got my little directions of what to do. So they actually tell me to ground out the power source to both the VVT solenoids, the back bank and the front bank. So I went ahead and did that. I'm not a big person to say back probe things, but you know, the car's high mileage and we're just trying to do a diagnostic here. If you wonder what back probing means when someone's checking electrical, this is what it refers to. So here is a connector to this VVT solenoid. If I disconnect it, I need to check this with it connected so I know the power source and the ground source. I've got 2 wires here. My schematic said power wire, and I double checked it by using my meter and checking the voltage, and I have a voltage reference on this red wire with this little white swirlies on it. So I took a little safety pin, not even, what do you call this? So I took a paper clip and I straightened it out and I back probed as gently as I could, try not to cut the wires or anything. That's why a lot of people are not, and I'm not, a big fan of back probing. But to diagnose some things, this is what we got to do. So this is, to me, the kindest way to do it. I've seen people take wires and shave them. That is just a nightmare. Please don't do that. So at this point, we're just gently back probing that connector. So, and I did the same in the back for that other VVT solenoid. That way I can ground out that reference point. So I back probe the back VVT and I've got the front VVT and I'm grounding out the power source. Got them all connected here and I got my ground wire. Now they want me to start this car up. They want me to start it up and run it. And instantly I should notice a RPM drop. If I don't, we got a problem. Secondly, while it's running, I'm going to tap the ground about 20 times. If I tap the ground and the idle doesn't fluctuate with like a timing advance, that means the cams are not working. So on top of a VVT solenoids that are probably frozen at this point, we might have cam problems. So don't just replace the VVT solenoids. It seems like it's going to be a whole nightmare of a job on this. Got cam sprockets, timing chain, and then a PCM reprogramming. So let's go that route. Let me just add a little 5-second thing here. I already did check, and I have voltage going to both of those VVTs. I checked with my meter. So I have voltage reference with the key on to both of them. So now I'm going to ground them out. All right, so now I've got all my wires back probed. I'm ready to go. And I'm going to ground it out through the body. And I want to see if I can hear the timing advance itself or de-advance. And watch what happens. Hear that? Well, that's good news. That means that the actual cam sprockets are good, chain's good. I just de-advanced it and advanced it by tapping the ground. So just as simple as hopefully replacing the oil, do a proper oil change, and replace both your VVT solenoids, and you should be good to go. And don't forget to clear your code. You don't want to keep seeing that light flash at you. Ooh, that was fun. So now that we've actually done the whole schematic, done the test, and we know that the cams activate when I ground out the solenoid, the VVT solenoid, and well, both of them at the same time. I ground them both out, and I click, click, click the ground. You could hear those cams snapping back and forth. That's a great thing. That means it's working. So we're going to replace the VVT solenoids. But before that, I want to show you how to test this compared to the new one on a bench with just a power probe or power and ground wire. I'm going to disconnect the connector first. Then we have 3 mounting screws. They're all a 10mm socket. Break them free. Make sure they're all the same length, so you don't have to be specific with the place. Just grab it and pull up. Now this is a carbon paper gasket, so we're just going to pull it up gently. Perfect. See the stuff left behind. Make sure it doesn't go down any of these little ports, little holes. I'm just going to take a razor blade and give it a quick little scrape. All right, so here's our new one that we're going to install, our new VVT solenoid. And we're going to test the old one. I'm just going to put these right in there. So we're going to test the old one by putting power and ground to the solenoid, and then do it at this one. Hopefully we can hear a difference. So I'm just using it's like a test light, but they call it a power probe. You can use a battery pack or the battery and just alligator clip to the positive and negative. Obviously don't touch them if you use your car battery. Don't touch them anyways, but you don't want to short your car battery out. So I'm going to turn the power pack on because we don't need the circuit to show. Now I'm going to put this on this clamp, that little piton, and I'm going to put it to this one. And we can see it grounds out because the circuit's going around. You can see that. And I'm going to add power. Let's see if we hear a click. So that new solenoid, that plunger is going in and out. So what happens here is you can't physically see it. See that screen right there? It goes all the way up of this plunger shaft, which is going to open and close due to oil pressure and timing advance. And it allows oil pressure. It goes by the oil pressure. That screen gets clogged due to lack of oil changes, and that plunger in there doesn't open and close all the way, and it sends a code saying our timing's not being timed. Like if you give it gas and it needs to advance the timing for a quick pickup, the transmission downshifts and the engine needs to advance the timing. It's not working because this puppy is not sending the signal to do it. So if you notice lack of power or anything and you get that code, this is a good contributor to it. You gotta do your oil changes. I can't explain that enough. So now let's do the same to this one. And let's see if we get any clicks. I mean, look at the solenoid. See the rust here, the surface rust? That also expands on the inside and it swells up that tin. This is just a tin cover. And those little electrode diodes, it's copper wiring spun around. It gets pressure on it and it's like, dude, I'm not gonna do what you want me to because I'm not functioning. Actually, let's see if we can see any crudding on that screen. The screens are just pretty brown from crud, but look at that. See right here? It looks like there's a sludge built up right there. Let me get one of these. See if I can get that. Some sludge right in there. And that's going to stop this plunger from going to its full function. All right, so there we go. I'm touching the circuit, and we're going to add some power to it. Oh, hear that? It's a small click. It's not a full, so that tells me it's probably just going partially up and down, partially up and down. It doesn't have the full range that it's supposed to have. Let's see if we can actually see that plunger moving. You don't want to connect the two together. Yeah, so that's that plunger. So we know this one has a better functioning to it. This one's partially clogged. So we're going to put this in, put the back one in, and do a complete oil change with the filter change and everything. Proper oil level, clear the codes, and we should be ready to go. So I'm just going to take a clean rag and I sprayed it with parts cleaner, like a little bit of brake clean, and I'm just going to give it a good wipe down. I don't want any oil residue or any carbon gasket left behind. Just want to make it as smooth as possible. So I've got the new gasket. I'm going to line it up, make sure it lines up with everything. Looking good. So to do that, to make sure it doesn't fall apart or misline up, I'm going to line it up here and I'm going to put 2 of the bolts through. Put the center one through. Maybe. Okay, and I'm going to put the bottom one. So we want the actual bolt to come out and line up that gasket. And then that space on that bolt is called a shank. Once that gets past the threads that are inside, we're ready to go. Always hand start. Now you hear that gasket just bottomed out. And that sensor can't move around, the solenoid can't move around, so we should be good to go. There's a torque spec for this, so we're going to tighten it down in the manufacturer's specs. But I'm just going to put it all on by hand, so I know that that gasket's not pinched at all. Snug the middle one up first. You don't ever want to use an air tool or even a high electric impact gun on this, because you can damage that gasket and you don't want to do that. So just bottom them out so that they're all just snug. And then torque them to spec. Torque spec is 8.9 foot-pounds. Now take your connector, line it up, and push it till it clicks. So now we're going to do the back bank, which is the right side bank, VVT solenoid, and this is where it's located right here. You can see it. It's got the 2 bolts, and the third one is right down there. The connector is down in the back. I can put my arm down and undo it, and you might actually be able to get it from the bottom and go up. If you can sneak in a 1/4 inch extension and socket and undo that, and take the bolts out and then slide the VVT down without taking this upper plenum off, then go for it, you know. Less work, the better, but sometimes it might just as be easy just to undo the bolts and see the gasket condition. It is a metal gasket, that's the way the factory does it, and sometimes they're not damaged, but just make sure you get the torque specs and torque the upper intake back down. So now that we got both our VVT solenoids in, and we did an oil change, because you've got to do the oil change, and I cleared the codes, we're going to take this little puppy out on the road. We're going to drive it around. The code should not come right back. Even if there is another faulty circuit in that system, it's going to take a while to come back. But I'm pretty sure we did what we needed to do. It passed and it failed all tests. So that's kind of a standard VVT solenoid test. So hopefully this video helped you out and you enjoyed it. If you're not a subscriber, please subscribe, and don't forget to ring that bell, because then it turns on all your notifications and you won't miss a future video.